Remember, this is the third video. My camera doesn't want to take long videos. This is the third video on the diversification that I'm doing. I'm doing nothing fancy, so I was just writing this. Okay, let me explain to you because I'm done now. So with the diversification that we are doing, we did 3 assumptions. These are the assumptions that we did. We assume that we invest equally on all our assets. We invest our wealth equally on our assets. That is, the weight of the wealth of either assets must be equal to 1 over n. That is, the weight of assets 1 must be equal to 1 over n. Assets 2, 1 over n. 2 assets n is 1 over n. We want this summation of the weights to add up to 1. That is the first assumption. Suppose that we invest equally on all our assets in order to achieve diversification. And then we suppose that the variance of asset 1, the variance of asset 2 are all equal to sigma square, as you can see. And then, oh, this was not showing. The variance of all these assets are equal to sigma square. The expectation, this is the third assumption, expectation of asset 1 must be equals to expectation of asset 2 equals to expectation of the end asset, which is equals to all mu. You can see this part is not showing, so I have to write here. Those were the 3 assumptions. If you can recall, what is diversification? Diversification is the minimization of risk of our portfolio. We want to minimize the risk of our portfolio with an addition of assets. Keep that in mind. We are minimizing this portfolio variance by adding more assets. Okay. And then I showed you the equation for variance. This is a general equation for variance of a portfolio. I showed you that is the summation from I is 1 to n, j is 1 to n, weight I multiplied with weight j, sigma ij. And then I showed you what is a covariance matrix. I did this, and then I told you that along our diagonal we have variances. Outside our diagonal we have covariances, which means that in our diagonal we have n variances. Like I explained a lot, I won't be dwelling this much. There is n of them, and then outside our diagonal line we have n squared minus n covariances. And then I did one assumption. I said suppose that the covariance between assets I and assets j is equals to sigma square over 52 for the case when asset I is not equals to asset j. When asset I is equals to asset j, the variance must be equals to sigma square. I explained that. I won't be dwelling on that much. And then I took this variance as it is because our first assumption said that we're going to invest equally on all of our assets. We're going to invest the wealth on all our assets. And then I replaced this wealth by 1 over n because of the first assumption that we did, this one. And then I continued, I came to this one. Thus far, you shouldn't be lost. You should be following on this path. And then I said we can have a case when I is equals to j. That is I. I replace that j with an I. And then we can have a case when I is not equals to j. Yeah? And then I'm actually adding that variance in a portfolio, because you can see in our covariance matrix, we have a case when I is equals to j along our diagonal line. I equals to j, I equals to j. And a case when I is not equals to j, as you can see outside the diagonal line. So that's what I'm doing. So when I is not equals to j, we remember that sigma ij is equals to sigma square over 52. That's what we supposed. This one. There is n square of this minus n. That is the cardinality of all these things, these covariances outside our matrix. It was not showing. Sorry about that one. And then there's n variances along our diagonal line. So I won't be explaining that much. We put that in, and then we try to simplify. I told you on the first video that I was going to stop here, but I'm trying to clean things up, and then I came to this. Now this is the part that I want to explain when it comes to diversification. Remember, with diversification, we want to minimize risk. We want to minimize this because variance it's a statistic tool that we'll be using to measure any risk. So we want this to minimize as possible as we can. So you can see whenever I'm increasing n, as n approaches infinity, this part tends to be 0, and then our variance will be equals to sigma square over 52. You can see that we have reduced our variance of the portfolio to sigma square over 52. You can see with the addition of assets. The more assets that you'll be having, the risk for or the variance for the portfolio will reduce to that. That's the whole idea behind diversification. Thanks for tuning in and watching this this summary. So we're gonna okay, now I think I'm done for this revision part. I think we're gonna find some time to do the minimization of that Markowitz problem, because it could be long. It takes a lot of energy to do this. I mean, I took like 2 hours to do all of these videos together because I had to delete and prepare and stuff. But we'll try to do the capital asset pricing model if we understand it very well, because we are almost done with that in our class. And we'll also try to finish that optimization or finding the Lagrange functions. How do we find the Lagrange functions when we want to minimize the risk on our on our Markowitz problem? But we'll try our best. Yeah, just give us time. Still that we're still working under a lot of pressure. We're having a lot of deadlines to meet. Thank you.